Okay, Rob, we've got 3 bundles there. So what's each bundle represent?
So we segregate our available veneer into 4 broad groups based on density. These are 3 of those 4. The 4 samples in process of being testing now.
Yep.
So our smallest pile is our highest density range. So it's working on about 800 kilograms per cubic metre upwards. So this is the sort of group we expect potentially the higher value type product, or certainly the most interesting.
Okay, so our second group?
Our second group is the next step down from our highest density. So this is I suppose the medium to high density, between about 600 kilograms per cubic metre up to 800 kilograms per cubic metre. So a lot of colour variation. There's no real correlation between colour and density. No strict correlation anyway. You certainly expect the higher density stuff to be darker, but there's not enough correlation there to warrant a grading process based on colour and density.
So they're both in the same density group, obviously?
Both in the same density group.
But they're quite considerably different colours.
Correct.
Yeah.
Stage down. So it's our light to medium density, I suppose you call it.
Yep.
So this is between the 400 kilograms per cubic metre and 600 kilograms per cubic metre. So again, some substantial variation in colour, even though they're within the same density range. So our 4th group, just a couple of examples here, is at the lightest density range we're looking at. So this is less than 400 kilograms per cubic metre. So overall, our available veneer we've segregated into 4. The lightest density working up to our highest density veneer. Yeah, so the idea of this trial is to have a look at the compressibility of coconut veneer at different density ranges. So the available veneer we've segregated those into 4 broad density groups, and we're undertaking a very controlled trial where we're pressing with big steel plate certain pressures, and we're looking at the amount of, I suppose, compressibility or how much the veneer actually indents at what pressures. So our drive for this is to really work out or establish what sort of veneer thicknesses we need at the back of the veneer lathe, what sort of control settings we need for the lathe, to ensure our final product doesn't have an unacceptable range of variation. So if we can assume, presumably, that lighter density veneer needs to be thicker than what the high density veneer is, so after pressing they come down to be similar or the same thickness. So the final product becomes quite uniform then and stable. So we'll continue to measure its thickness now. It's been loaded to the maximum load that we want to take it to, but from now we just want to have a look at the essentially the bounce back, how much that'll retain that thickness, or whether it actually continue to swell. That's right, Greg. So our 4 groups will go through the exact same process. So we're measuring how much each of these samples compress over different loadings, different compression loadings, and our end objective is to have a good understanding of how different densities will react throughout the product manufacturing process. So when all these are ultimately glued together and pressed to make a plywood or an LVL or variations in between, give us some good understanding of how the veneer is going to react throughout that process. So we would expect the lighter density veneer to compress a lot more than the high density veneer.
Yep.
But at present we really have no understanding of what the differences will actually be. So the end result will be a guide as to how to set up a lathe for producing the veneer to ensure we have the right thicknesses for the final product. So we actually may have some variation, we might chase or target some specific variation in veneer thickness based on density at the lathe, different to what you might do with a conventional healing process.